Hi, Mr. Hepburn here, and this is a quick video on precision and accuracy. So precision refers to the closeness of two or more measurements to each other. It also refers to the exactness of a measurement and how fine or small the divisions of the measurements. Accuracy refers to the closeness of a measured value to a standard or known value. It refers to how truthful and correct a measured value is. So for example, for precision here, high precision involves a tight range or a grouping of values. So you want the least amount of space between your values possible. So for example, here on the left you have 2.7 to 2.78. So that's just a small variance or range of 0.008, which is very small. On the right, we go from 0.70 all the way up to 5.78. That's a huge range of values, so it's definitely less precise. And you can see that on the dartboards below. All the boomerangs here on the bottom left are close together, so it's a tight range. And on the right, they're spread out. Even though the two groups may have the same average or experimental value, the one on the left is definitely more precise. If you take a look at measurement devices, if you have a smaller or finer divisions, then you will get a more precise measurement. So for example, an odometer in a car is a horrible device. It can be off by as much as 100 meters or 0.1 kilometers. A ruler is pretty good. It can be as precise as 0.1 millimeters, depending on the quality or the precision of your ruler. And finally, on the right, a micrometer is designed to be extremely precise, and it could be as precise to 0.01 millimeters, measuring the thickness of hair. Precision for timing devices as well. So an analog clock might be give or take 1 second, or a grandfather clock or a grandmother clock is only precise to the closest 1 minute or 60 seconds. And then you got your digital stopwatches, which go right to the 100th of a second. So they're very, very precise. As far as accuracy goes, high accuracy is close to the generally accepted value and has a small percentage error. So for example, if measuring the mass of a 70.9 kilo person, if you use a medical scale, which has been calibrated so that it should be accurate, you may measure the person to be 71.0. So you're only off by 0.1 kilos, and the percentage error is only 0.1%. So it's very, very accurate. A bathroom scale, an analog scale, okay, you can't really get a decimal with that. So it's not as precise. However, if you measure 72 kilos, that's very accurate. It's almost as good as the medical scale. Finally, on the far right, if you get a digital bathroom scale and it's not well made or it hasn't been calibrated, you may measure the person to be 68.7 kilos. Now you're off by 3.1%. That is your least accurate, even though it might be tied for precision. Okay, to tell if something is accurate, percentage error is usually what we use. So in one lab you may be measuring the value of pi. So one value of pi you may get is 3.025. And if you go through the calculation on the bottom left there, you'll see that we end up with a minus 3.71% error. So that means our value is almost 4% below what it should be. On the right, we have a value of 3.468. And when we calculate that percentage error, we get positive 10.4%. So it's on the positive side, but it's a larger amount of error, so it's definitely not as accurate. It is nice to keep the minus sign or the plus sign so you can tell if it's below or above the accepted value. Okay, so in summary, precision is how fine or exact your measurements are. Accuracy is how truthful or correct the measurements are. And a big common mistake is people do get confused with precision and accuracy. For example, if you measure pi and you get results of 2.14159 and 3.1, obviously the 2.14159 is more precise, but it is less truthful, less accurate. The 3.1, definitely not as precise, but it is more accurate. And that's it for this video.